There we are, we're on.
And we are live on the final day of our 2-week tech training program. Those of you that have been with us before will know that we will sit here awkwardly for the first couple of minutes and wait for everybody to join. So if you are joining, do not fear. You have not missed anything yet. We'll give it a couple of minutes and let everyone join before we jump in. Today we've got Darren is going to be leading the content around data. We've got Phil on Q&A and we've got Daisy in the chat. So hopefully another super engaging session. Darren, how are you feeling about your intro to the data landscape?
I kind of bigged it up on Tuesday, so I put a few fears into my head, but it's going to be an interesting conversation. There's a lot to go at, and I know this is one of the most requested ones, so let's give it a good go.
Yeah, that's what we like to hear. So we like to hear. I want a few curveball questions today, Phil. You know, make sure we've got those Q&As coming in from the audience.
Yeah, no. If we aren't getting many by halfway through, I'll just start researching some really tough questions myself.
You might want to put your camera up as well. What I can see is like from glasses down.
Say that again.
There we go.
There you go. Much better.
There we go.
I can't see myself, guys, so I hope it's okay.
All good.
All good. All good. So for those that are just joining, don't worry, you've not missed anything yet. We'll wait a couple of minutes for everyone to join before we kick off today's session. We've got some fun announcements today as well. So I know there's been a lot of questions around the wine club, around the quizzes. So we'll update everybody on all of that as well. What's been the personal highlight, Phil, of the 9 days so far?
He's gone, so a
Great. Phil's decided to boycott after 9 days, which is understandable.
So I would say my personal highlight. I'm actually quite so it's less of a highlight and more what I'm quite excited for post this. So I know that we were a little bit slow getting a bit of content into the Slack channels. But in the last day or so, there's been a few things dropped in. Dan dropped something really interesting yesterday about like a course for coding. So I like the look of that. So we go off that. So I'm looking forward to some engaging conversations that will come off the back of it.
Nice. Yeah, definitely agree. It will be really exciting to see what happens to that community.
What's your highlight?
Mine?
Your highlight, because you're back in the room now.
Yeah, and the door very quickly. Probably still the modern software engineering, but I think that's just more a lot of the things that I find quite cool about tech are involved in it. We're involved, in that. But having said that, so anyone who's worrying, what they're going to do next week and the weeks moving forward when they've got withdrawal from TRT, don't worry, we do have more sessions lined up. They're just not going to be every day. So we've got some really interesting topics I think Mark's going to maybe touch on a little bit.
Yeah, nice. I'm not sure whose microphone it is, guys, but there's quite a lot of noise coming from one of yours, so I'm not sure if it'll be. Not sure if something's moving about.
My AirPods in case it's mine.
How are we doing
on numbers, Phil? Do we want to kick off or give it another 60 seconds?
Let's see. Let's give it another 60 seconds and then we'll go. I think we're all right because I think most people are pretty familiar with those few intro slides. And normally by the time we get into the actual content, we've filled up. But let's give it another 30 seconds, maybe.
Cool. Sounds good to me. And bank holiday weekend, I think the team at Hackerjob have a very well-deserved bank holiday. I know Daisy is very excited about having a Friday off for tomorrow. So whilst we'll be in isolation and lockdown, I think the team have absolutely deserved a bit of a break after quite an intense 2 weeks, eh?
Yeah. No, well, and not just with the webinar stuff. I think as a business in general, it's been, which is strange, obviously, given the current climate, it's been a really, really busy time. So I think across the business, everyone's looking forward to that extra lie-in and a bit of extra chill time.
Very nice. Well, let's kick off. So welcome, everybody, to the final PRT session in the initial... Oh, guys, I'm not sure whose mic, but still getting some noise. But yeah, we'll carry on. Kicking off the final session, the first 2 week courses. Phil gave away a bit of a spoiler there, which we'll come on to in a second. Today we're going to go not too deep, more of an overview into the world of data, which is a very growing area at the moment. So as always, just a quick bit of housekeeping. The Slack group is now live, and as Darren said, over the last couple of days, it started to get a little bit more busy in there. So if you've got any questions, anything you want to discuss further, please chuck questions in there. We want to use that moving forwards. As you guys all know by now, asking questions, please add to all panelists and attendees. And if you're liking this, please get it out on social. You've got the hashtag TRT, the hashtag Tech Recruitment Training. We've been overwhelmed by the positive responses we've seen on social. So please share if it's been valuable. So in a second, I'm going to share the updated leaderboard. Obviously, there is still one quiz to go, which I believe Daisy will be posting in the chat now. It's tight. It's very tight at the top of the leaderboard. So we're going to have to get creative about how we decide a winner. But, we'll come on to that in a second. And the wine club, I'll share some stats, but it's going to be quite a big session in the wine club. So we have submitted an entry to the Guinness World Record book about the largest ever virtual wine tasting. So watch this space. You might be part of a world record. But drum roll, the leaderboards has not changed in a week. So these 6 people were top last Friday with 100%, and they are still top with 100%, which is quite remarkable. Clearly have great depth and breadth of knowledge across tech. So I believe you guys will be well aware that we will be drawing a name out of a hat virtually online to decide a winner if it is still tied come the end of today. You've got until 5 p.m. today to do the quiz, by the way. So please make sure you do it this afternoon. And we will live stream, probably on LinkedIn, the chosen winner, just so it's completely fair and transparent. So we'll do that at some point next week. But great effort, these 6 people. You're all winners. Just to share some quick stats about how overwhelmed we've been with the engagement from everybody over the last 2 weeks. So over the last 2 weeks, we've seen 700 recruiters join at least one session, which is quite remarkable. But the stat that's really blown us away this morning is people from 31 different countries have joined. So massive shout out if you're the person from Costa Rica that's been tuning in, or if you're the person from Senegal that's been tuning in. The tech recruitment training really has managed to go global, which was never our ambition, but truly amazing. And as you guys know, whoever has joined 6 of the 9 sessions will be joining the next wine club. So I suspect that's going to be a fair few of you. So watch out for an email next week. Those of you that are joining the wine club, you will need to fill out a form, which will basically just give us your address so we can send the wine to you. And then the wine list will be hosting the tasting over Zoom. So it'll be a very fun afternoon, I'm sure. And finally, we have now finished the course plan we had set out to do last Monday. So great achievement to anyone that's tuned into all 9. If you have missed any, they are available on YouTube where you can watch them back. But as Phil said, just giving the response that we've had, we're not going to stop these sessions. We are going to move them to weekly instead of daily because it is a lot of work to run them daily. And Phil and Darren do have day jobs. So we're going to move them to a weekly session every Wednesday, 12 to 1 on Zoom. If you are signed up already, you will continue to get the invite each week. If you want to unsubscribe and you don't want to carry on being invited, absolutely fine. Just hit the unsubscribe link and we won't invite you to any of the future sessions. Next Wednesday, we're going to be following up from this session today with an intro to artificial intelligence, which was the most demanded course so far. So we might end up doing a couple of sessions on AI. We'll see how we get on next Wednesday. So, Darren, over to you. Do you want to kind of give us a quick summary of what we're going to be covering today in today's agenda?
Sure. So, obviously, we spoke about AI just then. I think what we were keen to do before we move on to AI and machine learning, which are some of the most requested areas of data, we wanted to make sure that everyone is aware of the data landscape, i.e. what does a team in a current business in 2020 look like from a data perspective. So what we'll run you through is an intro to data team, so talking about different functions within data, a little bit about data science. Mark will then take you through data engineering, and then I will end it with some brief overviews of AI as a topic before we go into more of a deep dive next week.
Amazing, thanks, man. And of course, if you've got any questions throughout, please get them in the Q&A section or in the chat. Phil's going to be on those today, so as always, we want to make it as engaging as possible. So, intro to data. I know we've got a lot of memes in this session today, and as our friend here is telling us, with big data comes big responsibility. So no pressure, Darren. You've got that responsibility today. Give us an intro into the world of data.
Cool. So Mark clearly didn't know who that guy was in this last slide. For everyone, that's Uncle Ben. For any Spider-Man fans out there. So a brief intro into big data. So Phil summed it up perfectly the other day in terms of what big data is. So essentially, what big data is, in a quick summary, it's any data sets that are too big for one computer to handle. So we'll go through the explosion of data in a couple of slides' time, but you've got to think, like I said the other day, from a file size perspective, from a data perspective, when we launched a rocket to the moon, you could have put that into the same file size as what a current photo goes into. So like data and file sizes have blown up in the last few years. You're looking at gathering data insights from both structured and unstructured data sets. And then obviously, like Mark said, we'll be moving TRT to 1 hour next week with AI coming up first.
Amazing, thanks, man. So there are obviously, again, like we've seen in pretty much every discipline, a lot of buzzwords and a lot of synonyms for different roles. But do you want to maybe just talk us through, I guess, the 4 core roles that we see, 4 core responsibilities that we see within a modern data team?
Sure. So we'll run through a bit more about structure in a second on a following slide. But essentially, what a data engineer does, they're involved in setting up, maintaining of data structures that then support the business's information systems and applications. A data scientist is involved in developing and deploying like visualizations. So how can we utilize insight that is gathered through data to create models so that essentially then afterwards you can start analyzing trends and make predictions on it. So when we talk about data scientists, we're really talking about science. They do use hypotheses and come up with conclusions based on that. A data analyst is doing a lot of the insight analysis, but they are focusing more on reporting it back to the business rather than creating models and deploying those models. And then a BI developer is involved in the deployment of and maintaining of BI interfaces. So we'll kind of move on to that in the next slide.
Amazing, thanks, Daz. So I think this is an awesome image. I'm not sure who created it, to kind of giving that overview of what the different data teams, different people within a data team do. Maybe just talk us through this and what we're seeing here, Daz. Yeah,
absolutely. So what threw me off in the last slide was that they weren't really in the order of where they should have been. We should have spoke about BI development before data engineering, which completely threw me off. But if you look at this structure, it lays out quite well. So the stuff to the left, and what I will say is a lot of this is defined by the business to what responsibilities are for who. But historically, you're looking at the right-hand side, so all the cloud storage, gathering all the data from separate files and third-party AIs will be a lot of the data engineering stuff. They'll then be involved in a lot of the extraction, a lot of the ETL stuff, as you'll talk about a little bit later, Mark. So extraction, transformation, loading, and then BI developers and data warehouse developers, they'll be involved more with that side of things. And then when you get to the reporting layer, you're talking about people involved in data analysis and data science. So they'll be doing more of the visualization, looking at interactive dashboards for the businesses and utilizing reporting tools like Tableau that we'll go on to later.
Amazing. Thanks, Daz. Daz, I'm not sure if there's anything you can do. Sometimes your mic's cutting in and out, at least for me. So just be aware of that. I'm not sure if there's any way you can get closer or
let me get a little bit closer.
While Darren has a little little play around with that to try and get the sound quality a bit better. We've had quite an interesting question coming from Charlotte Marsden. So, our BI engineers sit in the engineering team rather than the data team. So I've often struggled to connect the relationship between the two. Is this structure the norm? So yeah, interesting question on team structures there.
Yeah, and I think it's going to very much depend on a case-by-case basis, I think, Phil. I'm not sure there's one holy grail that you would say this is definitely going to be in one team or the other. What I would generally say as a generalization is typically a BI developer is going to sit within a data function rather than a software engineering function. If you think about the responsibilities of different teams, typically a software engineering team that's maybe made up of front-end engineers, back-end engineers, is responsible for building the product, whereas a data engineer or a data team might be more responsible for gathering the data, structuring the data, analyzing the data, visualizing the data, which is quite often what a BI developer will do right at the end of this is visualization. So I think probably more often than not, a BI developer will sit within a data function. But, you know, as with all team structures, there's no real hard and fast rule. Not sure if you would add anything to that, Phil.
No, I'd just echo your point, really. I think we've seen it, you know, from working with hundreds of businesses, there is absolutely no right or wrong way to structure your teams, particularly when you're working with an agile way where you've got cross-functional teams anyway. We've seen very strict team structures where you've got everyone that's pretty much filling the same role within it. And then we've seen very varied ones where there's kind of a lot of knowledge share and things like that. So yeah, it really does depend just on your business use case.
Nice. So hopefully, Daz, you might have found a way to make the mic a bit clearer. If not, we'll crack on. So do you want to just give us, you know, we're going to go into a lot more depth on different roles and different technologies, but some of the different roles, or sorry, some of the different technologies that people might see on CVs or job descriptions when they're looking at a variety of different data roles.
Yeah, sure. Can you hear me a bit better now? Is that the sound quality improved?
That's a lot better, man. A lot better.
Sweet. Cool. Fine. So if there's any questions on the previous slides that maybe weren't very clear, feel free to chat them in and I can re-go through everything. That's absolutely fine. So Hadoop, when you think Hadoop, it's a term that you'll hear quite a lot, but essentially it's an ecosystem. So it's an open source software framework. So it's used for storing and running applications on essentially. So the reason you would use Hadoop or similar tools to Hadoop, because there's other ecosystems that you'll hear about, is they allow for like a cost-effective, reliable and scalable distributed computing, which I think Mark will go on to distributed computing a little bit later. Spark and Hive, so these are terms that you'll often hear. So Spark sits in and feel free to correct me if I get it the wrong way round, but Spark sits within the Apache ecosystem and then Hive is in the Hadoop ecosystem. So essentially, they're both used in very similar ways in terms of that they're used for performing data analytics on large volumes of data, but they're using in slightly different ways. So Spark is used for much bigger data analytic sets, and you'll find that if you're using Hive, you also use something called MapReduce, which if you are using Spark, you don't need two tools. So you might use Spark because it's all encompassing, whereas Hive, you utilize multiple tools across them. So again, it probably depends on the makeup of your data team for what tool set you'll use. Pig is a scripting language, whereas you'll hear about talking about the programming languages a little bit later with Mark. So it depends on what you're kind of doing on that side. TensorFlow is often a tool you'll hear about. So that's a machine learning framework. So I hope that most people in this session will be familiar with frameworks, given we've gone through them quite a lot. But essentially a framework is, or library is a set of rules so that you're not starting from scratch every time when you're running new projects. And then a non-relational database is something you'll hear a lot, especially when talking about big data. So non-relational is essentially a database that it doesn't follow the fundamentals that you would on a relational database. So it doesn't follow a row and column format. The reason that it doesn't is that it's much quicker to process that data because you're not having to grab whole columns or whole rows in order to run the data.
Amazing. Thanks, Dad. So I think we're going to jump onto data science next. But Phil, any other questions from the audience on just that kind of top level overview into the world of data?
Yeah, a couple very quickly. So could you sum up the difference between data scientist and a data engineer, please? So I mean, I could sum that one up very quickly. So in a basic sense, a data engineer will build infrastructure to extract the relevant data. So they're essentially going into that big data set to get you the right data points you need. A data scientist will use visualizations and other advanced kind of mathematical techniques to make sense of that data. So data engineers get you it, data scientists make sense of it in a very basic sense.
Exactly.
And then one other question. So what's the difference between a BI developer and a database developer? I'm not sure if that's something you might cover later on, Darren, so we can kick that down, or it's up to you.
We won't be covering it. I'll be honest that I consider them in a lot of ways to be almost synonyms for themselves. Like a lot of the tasks they're doing are fairly similar. There's some slight differences, but I wouldn't want to. I don't know how much depth I could go into that. If I'm honest, I don't know if you could pick that one up, Mark.
Yeah, and again, I think it's really important that whatever we say here will be caveated by people use these terms in different ways, right? So always have a look at either the job description or what the candidate said they have done to work it out. But it's kind of about the scope of the role. So a database developer, it's kind of an old school role now, to be honest. I don't think guys will ever see a very modern company using database developers. But a database developer was solely responsible for maintaining databases. That's all they would do. And normally relational databases. So you normally see that they'll be working with like Oracle SQL or some of the real old school databases. A BI developer, I think, was the comparison. I think just has a slightly wider scope. They might be touching databases, but a lot of BI developers are doing a lot of data visualization, building out dashboards, reporting, that sort of thing. So I think it's about the scope of the role.
Yeah. Cool. Thanks.
Cool. So moving on to our first sort of topic of today, I guess, a little bit more depth. We've got a quick intro into data science. So I'm sure there's going to be a meme on the next slide.
Cool.
Yes. Which is great. And by the way, Dan, I did know that was a quote from Spider-Man previously, though I don't know who this person is on the screen, but I love this meme. I think it's fantastic. So, Darren, why don't you just tell us, and Phil, you kind of touched on it there, but why don't you just tell us, what does a data scientist actually do?
Yeah, so data scientists, a lot of what they do is around kind of business needs. They sit within the landscape of data, but a lot of what they're doing is very business focused. They're focusing on data, but in a way that will help the business as a whole, rather than doing the engineering side of things. So what they'll be doing is using scientific methodologies in order to gain insight from all kind of data sources. So they'll be helping create strategies based on those interactions. So imagine you're using an e-commerce website, and what they will do is they will look at the journey someone's gone on for that e-commerce website. So do they need to set up some way to return back to the website or return to certain pages? So they'll look at trends that are going on that website in order to decide where people should be sent. They'll also do stuff around predictive modeling about, okay, this person bought this, therefore they might be interested in that. So when you're recommended stuff, that's a lot of the work that data scientists will be doing.
Amazing. And I guess this is really interesting, and I love the use of the word behaviours here, because I think a lot of the time, Daz, or the roles we've gone through so far over the last 2 weeks, a lot of it's been very tech focused, right? Like, I'm a software engineer, needs to know microservices and cloud computing, whatever. But it's really interesting with actually some of the strongest data scientists, as you've used the word here, the core competency is more behavioral based rather than technology based. Would you say that's fair to say, and talk us through some of the core behaviors?
Yeah, so they're still going to use a lot of technology, and they're still going to use a lot of software to do their jobs. But in terms of, I would agree that these people are very analytically focused. They're very curious in terms of what they're trying to achieve. So they want to understand the why a task should be done. So they're not just looking at data and then making decisions, which historically is what a lot of businesses would do. They would simply look at the data and not really consider, okay, why is this the case? Because you might come to a conclusion very quickly based on what you have in front of you. But if you're not looking at the trends within that, you may make wrong decisions. So they're there to think along that side of that. A lot of attention to detail. It's very difficult being a data scientist. It's very mathematical, and they'll be looking at huge data sets in order to make their decisions. Very statistical, like I say. And because they are business facing in a lot of ways, they need to be strong communicators, whereas not to use a sweeping brush across tech, but there's a lot of roles where you may not necessarily be interacting with both tech and non-tech on a day-to-day basis, whereas these guys will be.
Yeah, and I think that last point is absolutely core, right? You can't just be great technically as a data scientist. You need to be able to take those insights and communicate them to the businesses as to why it's going to drive business value.
Yeah, exactly.
Phil, any questions from the audience before we jump into sort of what a data scientist does on a day-to-day?
So we've had one question. It's actually on Splunk, which I believe, to be honest, is more of a data engineering tool. So I think we can touch on that a little bit later on.
Cool.
I know I've worked with Phoebe, who works with our data candidates on Splunk before, so I've got a bit of an insight into that. And then we had one more question. So how does deep learning relate to machine learning and ultimately to AI as an overview? So I think this is very in-depth. Cheers, Jack. So next week, we're going to be going really in-depth into AI, machine learning, all of those different concepts. So I think we can really sort of explore all of that sort of stuff in the next session.
Yeah, absolutely. I think Daz is going to give us a high-level overview today as well.
Yeah,
So Daz, kind of tell us about their day-to-day role. Like, what would a data scientist be doing on a day-to-day basis?
Yeah, so again, what I would say is about the data acquisition and data preparation. A lot of this could be done by other sides, but essentially, if you look at data science as a whole, the kind of tasks they might do. So you might find that they're having face-to-face meetings with the business to understand, okay, what problems are we trying to solve, and what insight do we need to gain in order to tackle these. Doing some data acquisition, so looking at scraping from various sources, as you would have seen in one of the previous slides. That could be from a number of different sources. Data preparation, so cleaning and transforming that data so that it's in a format that is likely to be useful, because you'll be getting them from various sources. All the data will be in completely different forms. So you need to make sure that they're in a form that can be utilized well. And then they'll be doing exploratory data analysis, so looking at the variables within the data set. So I'll talk about a lot of the kind of variables in a later slide. Awesome,
man. And I know you've got a second part to this, so do you want to just talk us through this as well?
Yeah, so predictive modeling, we'll be going through in another slide. It's one of my favorite parts of data science, because then you're talking about some stuff that was in movies 10, 15 years ago, like the Minority Report, that we thought was so futuristic, but it's very much here now. And then visualization, so that we create reports using different technologies. So I don't know actually if there's a slide on it, but you'd be using tools like Tableau, ClickView, Power BI to create reports in a way that's visible to the business. So you'll be using stuff like graphs, you'll be using stuff like charts, and making it visual, like the word kind of gives away, so that when you're sitting down with a team, you can go, okay, these are the trends we're seeing, rather than you having to look at thousands or millions of data points in order to work out what it's saying. And then they'll be deploying and maintaining the different models. So like I said on data analysts, a lot of the time the data analysts won't be creating like future models for how we're going to continue to analyze this data, whereas a data scientist will be thinking about the how, the why, but also what can we do in the future to make sure we're still capturing this data. See if there's any trend changes over time.
Amazing. It makes complete sense. And as you touched on, some of these roles in a fully fledged data team might be carried out by other people, but I think it's a really cool end-to-end description of what they might do. And I think we're going to come on to now one of your favorite topics, as you just touched on there, which was predictive modeling. So what do we mean when we see predictive modeling on a CV or job description? What's the concept?
So essentially predictive modeling is looking at, a lot of people will think predictive modeling is just looking at the future, but a lot of time you're using statistics to predict likely outcomes, but also you can do it on post events. So it's used a lot of time in e-commerce. We'll run on to Netflix later, which has some kind of the machine learning, but also some predictive modeling in it. But it can be used on crime prevention. So if you're looking at a crime post-event, what you can do is look at the variables like, okay, who's likely to have been in the area, who have we got in our crime database that would meet with, what is the description of this person and within our database, who fits this description, and then you can do almost like Minority Report on it. So you can then look at, okay, who is likely to commit this event, so we can then start meeting up with these people and having conversations so we can come to a conclusion on who did it. So you'll find predictive modeling is used across all different industries. I think what the FBI is doing on predictive modeling, and I can send some articles on that afterwards, is fascinating. They're using it in really innovative ways.
Amazing. And yeah, please do share those FBI articles. I'll be interested to see what Big Brother activity they're up to. So it'll be very, very interesting to watch. Phil, any questions from the audience on predictive modeling or the day-to-day role of data scientist?
No, not just yet. I think everyone seems pretty happy.
Nice one. So moving on then, Daz, data science isn't necessarily a new topic, though it has obviously come into the fore a lot more recently. I think this is a great image that you found to just kind of talk us through, I guess, the two schools of thoughts when it comes to data science and how they've kind of converged over the more recent years.
Yeah, so if you look at data science historically, it's kind of broken down into two different areas. So you see it on commercial. So there's a concept called Taylorism, where essentially what you're looking at is how can we improve production by looking at how long it takes for a product to be made. So what he was looking at is, okay, we've got to make this many products. This is how long it takes to make this product. How many people do we need in our team in order to achieve this? Whereas if you look further along, then you get to Keynesian, which is looking at incremental changes. Like anyone that has done a business degree will be aware of these concepts. Is looking at making incremental changes and then what effect does that have on us? So analyzing the data from that. And then you will have the thought where from an academic perspective, it's also huge. So you'll find that Cambridge, for example, they do a lot on biotech. And you might find someone that is doing a PhD, a master's, etc., for like 10, 15 years, still utilizing data science but in a complete different way. So they're two diverging fields that have come together in the last few years. And then you get to the 1980s and mid 80s, and then Excel comes along as a tool and changes what we're doing with data sets, because you then can start doing really innovative work around relational databases. So that kind of changed things forever. But then you get to the early and mid 90s, and we've all kind of lived through the dot-com boom, which changed the way that we as consumers interact with products. So suddenly we went from interactions like going to shops to now we're using it from an e-commerce perspective. So services in the early 2000s like Netflix, Facebook, and Amazon, they changed the way that we viewed our content, the way we shared our content socially, and the way we shopped. And then by the time we got to the 2010s, you then started getting stuff like Uber, Deliveroo, Airbnb, that again are changing what we're doing from a consumer perspective, but coming through phones. I know from my side, I pretty much sit on my phone all day, so I'll be interacting with different channels and different providers all the time. So they'll be gathering data on what I'm doing. As you said, kind of Big Brother always knows what you're doing. And I know that Facebook have gotten a few problems in the last few years for what they're doing with data. And then as we get into the more recent years, we then start learning about machine learning and AI, and it kind of hits the mainstream. They're two concepts that have been around for a long time, but it's only been in the last few years that really they've hit mainstream.
Amazing. Super for our history of data science. And I think we've got a similar slide on the history of AI coming up later as well, where we'll go into that in more depth as well, because again, a concept that's been around for a lot longer than what people might imagine. So you've kind of touched on these, but talk us through the main tools that a data scientist would use and how they might go about using them.
Sure. So, like we say, when we talk about data modeling, what we're essentially talking about is creating like a framework of a relationship between the database and using it from a business insight perspective. So you'd be looking at like Python, R, and SAS from that side. Data visualization, I didn't realize that I had this on a slider. I've completely forgotten. So obviously I spoke about Tableau, ClickView, and Power BI. You'll often find on a lot of older data science CVs. They might use Excel from that side as well, because you can use Excel, of course, from a data visualization perspective, but it's just a lot less in depth than what you would get on the newer technologies. And then from a simulation side of things, MATLAB. Anyone that's a big fan of F1, it's probably the best example that I could give. So MATLAB is essentially a simulation tool. So what it'll be looking is the data points of when a car is going around the track and doing its times and stuff like that. It'll be simulating, okay, what changes can we make to make incremental gains? So looking at the Keynesian model is still utilized in a lot of data. Hopefully that's given a bit of an overview. You'll see MATLAB in particular, like an F1, aerospace, and automotive firms.
Amazing. And on MATLAB, Daz, like, is it considered a bit of a legacy tech, or is it still very much, you know, the main technology when it comes to building simulations in those industries?
I would say currently that there's some, and don't probe me too much on who the future players in it, but MATLAB is still, it's a little bit like like SQL, where it's a tool that has been around for a long time, but because of how it is built so well, it's still utilized as like the main tool within the simulation field. So it might have some limitations, but it's a tool that has been used across all industries for so long that they're kind of building on it constantly. So like think Java, if Java's an old tool, if you continuously build on that tool, it means that you don't really need a new tool to take over. So there's other players in the market, but I still find on my side that MATLAB is still the most requested when we're looking at simulation. Phil, you see a lot of CVs. I don't know what your thoughts would be on that.
Yes, obviously, well, CVs and just any candidates that kind of sign up from all various sources. Yeah, you still see it a lot. I know Jaguar, Rolls-Royce. So yeah, definitely exactly. In the automotive industry, still see it on a hell of a lot of CVs. Alongside, it's normally MATLAB and C++. You'll be getting within those industries. Yeah.
Yeah.
Awesome. And then there's a couple of other tools here, Daz, that you've also listed as well. Do you want to give us a quick overview of these?
Yeah, sure. So when we're talking about querying, what we're essentially talking about is the action retrieving data from your database. A lot of what you'll be doing in SQL is going to be relational databases. Running models, when I talk about running model, I'm talking more about like cloud storage, as you would have seen in the previous slides. I'm talking about where the models will sit, because of course, when you develop a model, you still need somewhere for it to be stored, because otherwise it's useless, because on a day-to-day basis, it could be grabbing millions of data points from your customer base. So the models will sit within AWS, Google, or Azure. And then as we kind of went through earlier, then you'll have machine learning libraries, which is like TensorFlow and Keras.
Amazing. And just touched on that AWS, GCP, and Azure. It's interesting, right? Because we'll quite often see a requirement for people within the data field to know cloud computing. And again, it just shows the importance of cloud computing. Obviously, Phil and Yuta did a fantastic presentation, I think, on Tuesday, going into cloud computing in a lot more depth. But, you know, big data teams will absolutely be using cloud computing, and even DevOps engineers. I know, Phil, we've done quite a lot of work in the past on DevOps engineers within the big data team, where they combine cloud knowledge with some of the configuration management, containerization knowledge, with some of that Apache and Hadoop and Spark knowledge. So it's interesting to see how all of these technologies are very interrelated in modern scalable systems.
Yeah, well, I think if you think of big data as Darren touched on, as data that's too big for one machine to compute, then cloud, you know, has to come along with that. If it's too big for one computer to compute, then unless you've got, I don't know, some weird like wide access network, really you're going to be relying heavily on the cloud to do anything with it.
Yeah, and it takes us really nice into data engineering as well, because the concept of distributed computing comes up a lot when we look at big data as well. Before we go into data engineering, and we're only going to briefly touch on data engineering today, it's probably a session in itself if we want to. Any questions, Phil, on chat or Q&A on anything data science related before we jump over to data engineering?
To be honest, no, not just yet. I think can maybe touch on Splunk at the moment. So from what I understand, Splunk spans both data engineering and data science responsibilities. So it was brought in to kind of collect and analyze machine-generated data, and it'll basically connect that data to a really easy-to-use interface. So it'll both extract the relevant data for you, as well as help you with understanding it via quite a nice used interface. That's the understanding I have from a bit of research a couple of weeks ago, anyway.
Nice.
I think that's a good overview of what Splunk does.
Awesome. So, quick intro, another meme. Darren, you stuff these presentations full of meme. Yes, there's no point in having all of this data if we can't use it. And fundamentally, the data engineers are critical in making that happen. And it's a really important distinction. I think it's getting better, but we still see a lot of requirements that is kind of conflating data engineers and data science into one requirement. And it just means from a recruitment perspective, it's going to be much, much harder. You know, it's like looking for a native iOS and a native Android developer in one person. It's going to be a really big challenge. But fundamentally, what the data engineers do is take the data from all of the various data sources and prepare that data to be analyzed by the data scientists. So if you think about it, businesses are going to have hundreds and thousands of different data sources. Might be their own databases, might be third-party APIs, could be sensory data if you're looking at F1 and things like that. And it's all, well, quite often in a big data world, stored in an unstructured way, which means, as Darren did a fantastic presentation on last Thursday, there's a lot of different ways you can store that data. It could be key value, it could be graph-based databases, etc. So a data engineer is effectively building data pipelines from all of those various different sources and then storing that data in either a data warehouse or a data lake for the data scientists to then analyze them. So an analogy that I saw that I liked was they are the plumbers, if you think about it, or there's a very common phrase used now, which is data is the new oil. So if you think about that analogy of oil, you might have a great oil rig that discovers oil somewhere, wherever you find oil, maybe off the coast of Scotland, I think. But you need all of the oil pipelines to be able to transport that data or that oil to somewhere useful. And that's what the data engineers are doing. How they do it will really vary depending on the type of organization you're looking to recruit. So some of the more what might be considered legacy data engineering skills might be data warehousing or building what's known as ETL pipelines. So ETL pipelines stand for extract, transform, and load. So you're extracting data, you're then transforming it into a way that is then loadable into a storage place. The problem or the challenge that businesses had with ETL pipelines was they were batched based. So if you think about it, you know, a program, an ETL program would complete one batch, maybe once a day. Whereas what you've seen now is a lot more real-time processing of data pipelines. So it could be called real-time processing or real-time streaming. And that's utilizing tools like Kafka. So quite often you'll see data engineers in a really modern environment building data pipelines with real-time streaming using Kafka. So slight difference between how organizations use data engineers and what they'll be doing. On the more complex side, as Phil just touched on there, we're definitely going to be using cloud computing and big data, and quite often we're going to be working on distributed systems. So for those that joined the session last Friday, you'll know distributed systems is basically storing data on multiple computational entities at once. So that could be on different nodes within the same computer, or it might be on different computers in a network, all of which has got its own local memory. And then there's this other concept, which is similar to some of the other things we've discussed, what is called parallel programming. And that's effectively, as the name would suggest, running multiple computer systems in parallel to complete the same task. So if you're working on a really complex task, you don't want to have one computer running it because it's going to take longer to complete. If you can have that task running over multiple computers or computational entities, it's going to get completed quicker. And the key thing about a data engineer versus data scientist is they need really strong programming skills. So your data engineers should be able to program as strong as your software engineers. It's just they're using those languages to do slightly different things. The three main programming languages we'll see in a data engineer is Python, Java, and Scala. All of them can obviously be used to build web applications as well, but they're the main three we will see. So there are a load of different skills within data engineering, but I think the core premise is building those data pipelines, and that might be using ETL, or it might be using sort of real-time streaming, real-time processing. And I think the big thing when you're looking at candidate CVs is really focus on what they are doing. So I wouldn't really worry about whether they're calling themselves a data engineer or not. Focusing on what they're doing. Are they building real-time streaming data pipelines using Kafka and distributed computing, distributed systems? That's going to be someone that's at kind of the cutting edge of data engineering. Or maybe they're using data warehousing and ETL pipelines, and it might be in a slightly older environment. Sorry, Phil.
Sorry, I was just going to say, while you're on that topic, we had a quick question about Scala and kind of the rise of it within data engineering. And I guess from my side anyway, I think one of the reasons we've seen that is obviously it's a functional language. So if you think back to what we were discussing, I think it was last Friday, when you talk about functional programming language, you're giving the computer the end result essentially and allowing that to work back and get to it. Also, I think Spark is written in Scala, so they work very well together. So if you are going to be using Apache Spark, which a lot of data engineers are, then Scala is a really compatible language for that. And obviously Scala is, it's short for scalable language. So when you're talking about working at scale and you're talking about, huge data sets, then again, it's a good fit. I don't know if you'd have anything to add on that, Mark?
No, absolutely spot on, Phil. And I think we would see Scala being used way more in a data environment than in a web environment. I think absolutely spot on, Phil.
And then one more question from Charlotte Marsden. So it refers back to your plumber comment. So how does this compare to a data architect? A hiring manager in the team described a data architect as a plumber. So wondering if they're really similar roles. And I think it's probably similar to your earlier answer on kind of what you call someone within a business.
Yeah, so if you think about an architect generally, and actually probably worthwhile going back a slide because this slide, when you look at the second point here, does actually talk about architecture. So if you think about an architect generally within tech, they are responsible for the overarching system. So they are designing, quite literally like an architect designs a house, they are designing the system. So a data architect is building or designing, rather than actually building, designing your overall computing power that is going to process your big data analysis. So a data architect will be looking at, are we using distributed computing? What cloud platforms are we going to use? How are they all going to work together? They'll be heavily involved in the tech selection. So are we going to use Spark with Scala, or are we going to use Python and something else? So they're building the overarching or designing the overarching system, and then people will go in and build the specific layers. So normally a data architect is one of the more senior people within a data team, and you might only have one or two of them. And then the data engineers are going to go and actually build those data pipelines. And the data scientists are going to be the ones that analyze the data, but the data architect has designed the system. Very similar to how a cloud architect would design the way their cloud computing setup is going to work. Very similar to how an application architect will design how their software frameworks and software architecture is going to work. They're more focused on design rather than build.
Great. Awesome.
Cool. So I think moving on to the final thing that we're going to cover before we jump into some Q&As is an intro to AI. So what is it, Daz? I think you've got a perfect definition on this slide with another meme, right?
I believe so. What, on this slide? So essentially that's, I didn't realize you meant this slide. Essentially what we're talking about there is that when you type anything into like Word, that it will start assuming what you're going to do. And I often see it in my Gmail that it will start talking to me and going, okay, like this is the word you're looking for, when a lot of time it's not. So what AI essentially is trying to do, it's perceiving an environment around you and taking actions based on what it's done before. So it's looking at, okay, what has happened before and what assumptions should I make in order to define what's going to happen in the future. So AI as a whole, people think about it, like I said, like a new concept, but it's been around for like a long time. So the Turing test, what the Turing test essentially was can a computer trick a human into thinking that it's also a human? So it happened back in 1950. and then you had a chatbot that was called Eliza. And what Eliza was doing was, it was developed by MIT, and it was to have a conversation with humans. So it's the earliest known version of a chatbot. Then you get to the end of 1966, and you have, and I think you had another term for it the other day, Mark, but you have an AI winter. What an AI winter is, it's a period where there is no innovation. So we got to the point of what can we do within AI with the technology we've got at the moment. And then we came out of that winter in 1997, and this is quite a famous case of AI. So there was a system called Deep Blue, which played I think he was the 8-time world champion grandmaster in chess. And it's developed by IBM, and it beat that world champion. Then you get through to 1999, and I suspect most people have seen these dog robots before, but they were developed by Sony, and you see them a lot in places like Tokyo during the 90s. And then you've got Roomba. So Roomba, if anyone doesn't know, essentially is a vacuum that is allowed to go around your floor, and it will look at and model images in its system to work out what your room looks like. So over time, it'll go from what it looks like when it first starts, where it'll be bumping into walls and trying to figure out your room, and over time it will change before it even reaches rooms, so it'll be learning as it goes. And then you've got IBM Watson. A famous case for IBM Watson is it went on Jeopardy, which is a really big American trivia show, and it won over $1 million on Jeopardy. So incredible scenes on that. And then you get to Alexas. I think most people either have got Alexa or know someone with Alexa. They're everywhere now. So Alexa will look at your speech patterns and your tones, and it will obviously send you to wherever you want it to send you to. But also you can ask it stuff around, okay, like Alexa, play me some country music or something like that. And based on your speech pattern, it will then decide, okay, what area of that genre should we look at? So we should look at something upbeat. Should we look at something that's a little bit slower? So amazing stuff on that. And then the final, it's a few years ago, but the final case I want to give on AI, a really famous case with Microsoft. So there's a Microsoft chatbot that's called Tay. Tay learned so much and so quickly that it then started sending out inflammatory and fairly racist comments on the internet. So they had to close it down quite quickly. But it's the most recent example of AI and how, if you don't have control over it, it can start making decisions that a human knows are wrong, but a computer doesn't.
Absolutely, and
kind of a brief history.
Yeah, and absolutely spot on, does. And obviously next Wednesday we're gonna spend the whole session going into AI, but I think a couple of things to note, building on what Daz said there. The Turing test is something is really interesting, because in AI you have what's known as narrow AI, which is basically artificial intelligence that can complete like a really specific task. So an example of narrow AI is Deep Blue playing chess, or AlphaGo playing Go. But for like the cutting edge researchers in AI, what they're trying to create is artificial general intelligence, which is basically what the Turing test shows is, can you have a machine that tricks a human into thinking that it's a human? And we're not there yet. We are, depending on who you speak to, either decades or centuries away from creating artificial general intelligence. But why it's become so prevalent again is because of a lot of the topics we've discussed today. So two main things that have enabled AI to come back to the forefront after that long, deep winter was, one, the computational power. So the sheer power of the machines we have today compared to what they had in the 50s, 60s, 70s, etc., means that we can, secondly, process the data sets that we've got today. So Darren's going to come on to next, the most common AI research methods and techniques, but a lot of them are using vast amounts of data to learn. And that's been prevalent and possible because of everything we've discussed today around the collection of big data. So just moving on to those techniques, and I know we are going to spend Daz next Wednesday on this, so we maybe don't need to go into too much depth, but you mentioned here a couple of the core techniques, and I think something that's really important to note as well is quite often artificial intelligence and machine learning are used synonymously, but they're not. synonyms, right? Artificial intelligence and machine learning aren't the same thing. So maybe Daz, just give us a little bit of an overview of what the techniques are.
Cool. So machine learning, what you're looking at there is, like I say, a Roomba. So it's looking at how can the machine learn, these are all subsets of AI really. So machine learning, the Roomba will go around your room and start modeling your room, like I said in the last one. Deep learning is about learning from repetition, similar to Roomba, but it's learning from like experiences. So if you look at stuff like service bots, so I know that we did a physical meeting a few months ago, Mark, with a couple of the big banks, and they were talking about their chatbots. And what will happen from a deep learning perspective is it will complete repetition over time, and it will start learning from the kind of questions that are coming up and start learning the answers to those questions. So over time, unfortunately, and this is the world of data science, a lot of what they're doing from that side is putting themselves out of business. They're automating everything to the point of that they don't need humans to do these tasks anymore. So a lot of chatbots now, you'll know, will ask you, like Vodafone's for example, will ask you questions, and it will go to the point of, can I answer this question? And then once it gets to the point where a human can't answer it, whether it's because of data perspective, or whether it's because legally they can't know the answers to these questions without there being a human involved, that's when it will start pushing it across. Computer vision is looking at understanding the visual world. So it's being used a lot in the current COVID situation. So what it can do is look at your phone and when you're on your phone, it can look at the distance between yourself and another human. And then there's something going on in South Korea at the moment where they are going to have an alert. So if you're too close to another human during social distancing, your phone will buzz, and then you'll be told to move away from other humans. So it understands the visual world. And then natural language processing is looking at stuff like Siri. So it's looking at the speech patterns and taking like milliseconds to decide about, okay, what should we do on that side, and understanding like requirements within the way you speak.
Amazing. Thanks, Daz. And Phil, I'm sure that we have got tons of questions because AI is everybody's favorite topic to discuss right now. And it is absolutely the biggest buzzword going around right now. But I think let's hold off going too deep until we do the session next Wednesday. I'm just conscious of time. I think we've only got a couple of minutes left. So unless, Phil, there's any, quick questions that you'd like us to answer, I think we can hold off on a lot of the AI stuff until Wednesday.
No. I think we've just one thing to mention. So we've had a question around whether quantum computing will be in next week's presentation. So yes, we'll make sure that we cover quantum computing probably towards the end. It's definitely at the advanced end of computing, and as you've touched on, Jack, in your question, not fully formed yet, but yeah, we'll definitely go through that.
And I think, just to kind of build on what we were saying, quantum computing is all around increasing the computational power, which is what processes these large data sets and processes these techniques. So absolutely, we can include that. Cool. So Daz, I think why don't we end this mighty 2 weeks with a quick example of how Netflix are using, I believe, machine learning, but you're going to correct me if I'm wrong there, to influence what we watch.
Yeah, sure. So yeah, it's a subset of machine learning. We can go into further detail next week, but essentially everyone will know what Netflix does in terms of when you log onto Netflix, you're given recommendations about what you should do. So they're kind of at the forefront within their industry for how to do it. So what they're looking is customer behaviours, buying patterns, etc., to guess what you're looking for. And I know when I go onto Netflix, I'm given way too many options, which means I never finish anything. But that's kind of what they're trying to do. They're using the behaviours of what you've done in the past in order to define what you might do in the future and keep you as a consumer. So looking like consumer patterns in the broader sense. Again, I could give quite a good article on Netflix. I appreciate we've only got 3 minutes left, but really interesting what they're doing at the moment around machine learning and predictive modelling. Yeah,
it is, and it's one of the most advanced data science teams probably anywhere in the world on what they've built with their recommendation engine. So an amazing case study in how a business is leveraging data. I can't remember what these challenges are, so I'm intrigued. So why don't we just end up? We got another 2 minutes or so. Phil, why don't you just give us your very quick take on this question? So we often get in data analysts applying for our data science role. Are they different disciplines? Probably some similarities here between DevOps and sysadmin as well. Phil, what's your take?
Yes, they are. To go into a bit more depth, so a data scientist will absolutely be involved in analysing data. They need to be involved in that analysis process in order to create the visualizations and make that business sense out of it that they could pass on to other stakeholders. But it's absolutely not everything they do. As I've touched on, there's the statistical analysis. There's not just statistical analysis. There's the visualization. There's presenting to the business, a whole kind of wider remit for them. Whereas a data analyst is focused primarily on just extracting that meaning from the data. That's my understanding of it. Anyway, I don't know if you guys have anything to add.
Yeah, so one of the funniest articles I ever read, and it was a couple of years ago, but I think the title was "A Data Scientist is a Data Analyst that lives in Silicon Valley." And I think that's an interesting way to look at it. But when I think data science, I think of that they aren't just looking at the data that's happened before, they're looking at the future of what will happen with that data. So they're more thinking about, okay, what's happened before and how can that influence the future. Whereas the data analyst from my side is looking more at the data that's currently there and using it to talk to humans about what do we want to do in the future, but not particularly creating something that can model that and look at trends in the future, if that makes sense.
Yeah, and I think we see it in the tech stacks and things like that. When we have companies come to us and ask for a data analyst, typically, and it doesn't always pan out this way, but more often than not, we're asked to find a data analyst that knows SQL or Python, and that's largely what they're after. When we're approached to help with data science, there's typically a lot more skills involved in that, visualization tools and all of that side of it.
Yeah, absolutely. Amazing, guys. So I think we've just hit 1 o'clock. So on that note, we will wrap up. So I think a huge thank you to everybody that has tuned in over the last 2 weeks. It's been an amazing experience for us. Massive thank you to Darren and Phil for all of your insight over the last couple of weeks. I guess a couple of things to highlight. We will be announcing the quiz winner early next week. So those 6-way tied for the leads. Please make sure you finish your quiz today, because it would be horrible for you to do 8 quizzes and fall at the final hurdle. And we will then give out the £500 Amazon voucher there. For anyone that's attended 6 sessions, you will get an invite next week to the wine club. Please fill out the form promptly so we can get the wine to you in a speedy manner. And finally, just to highlight, this series is going to continue. So we're not going to do daily sessions, but we're absolutely going to do weekly sessions. So next Wednesday, 12 till 1, is an intro to AI. You do not need to do anything. If you're already subscribed by joining this session, you will automatically get an invite. If you don't want to get those invites anymore, as I said, you can easily unsubscribe. But just a huge thank you. Massively appreciate the support from everyone over the last couple of weeks. And have a great bank holiday weekend. Cheers, guys.
Thanks, guys.
Bye-bye.